close the door. I'm starting the music. Okay, audio clear. Arindu, water you want? Water. Hi, good morning, everyone. Very glad to see so many of you have already joined. Okay. So while we will go ahead and I have got some good inputs yesterday on how do we make the screen bigger so that you will get to see the screen. I'll try and improve on that today. See what is the best way that we can work on. And I'm hoping you remember what we discussed yesterday. And very quickly, I'll have to necessarily mention the credits where we have adopted this information from Stanford University primarily and many other organizations that are there who have contributed to this, or rather I adopted from. And right from Andrew, today we will look at a lot of work of Drew Hudson, where how he has articulated the machine learning steps. There are also other members, some of them who helped me put together the data. They have been very helpful. Very quickly, I will share a recap of what we discussed yesterday. We began with looking at what is a modern day professional experience, and we said right from the time the person wakes up, a lot of AI based tools are assisting the individual in terms of where the person has to go, what are the things needs to be done, and how much effort and time does it take to reach, and so on. And there are also these automated cars that are coming up in developed countries. They are already there. We spoke about them, and we also looked at many other areas where machine learning and artificial intelligence has contributed, and how it is already pervasive, and some of us, or rather many of us, are experiencing one or more of these areas. Then we looked at after having inspired by the kind of impact it has, we then looked at this very important aspect of what machine learning is. Here we tried to compare with what is how does humans learn and how machines learn. We also looked at different intelligences for humans, that is cognitive, emotional, and spiritual, and machines are mimicking the cognitive intelligence here. Then we looked at the basically from the past experiences, it is the pattern that does the magic. You look at some set of input variables and then try and see whatever you want to have as an output, connect that. As an example, if you have seen a person who is your friend, fellow professor in the college, and the person has joined on that day, and once you saw him a brief introduction, and the following day you can recognize the person. How are you able to recognize that person? Because the facial features of the person are sort of impinged in your memory cells, in your brain cells. So that's how you have now put together some data around the facial features of the individual, the kind of hairstyle, ears, nose, and the body, and the voice in which the person speaks. All of this you have memorized in the mind. And the following day, when you see the person, you can immediately say, hey, this person is so and so who joined our college yesterday. So that patterns identification, memory of it, and then recognizing the following day is what happens. Now, the beauty with the human mind is you see a person once and you can still identify who the person is, while in the case of machine, it is not that easy for the machine to understand, label the individual by looking at the facial features input once. So, of course, you can always, once you label it, it will not forget. It is about how you can replicate Tomorrow the person comes with a different, let's say, beard. After 1 month, this individual has grown beard and mustache. Probably you can recognize easily. For machine, it takes a lot of efforts to recognize that. That is also possible. I don't say it is not possible. This is about that recognizing. It is about storing the memories and so on. We looked at these aspects. We said that typically in machine learning, there are three equations that matter. Everything, all the input values, in this case of the professor's face, the facial features, the nose, depth of the face, the color, all of this is become input variables here. Now that gets squashed with some sort of a processor, and that is f of x we spoke about, and that helps doing the pattern identification or pattern connection with a particular output value. Here in our example, the professor's name. All right. We also spoke about while this is the pattern recognition or the in linear regression terms, so we talk about the correlation between the input values, that is these facial features, and the name of the person, that is the label of the object. So that correlation is established through some sort of a processing here. And then we took example of linear regression yesterday, and we said it is y is equal to mx plus c, where m and c are correlation coefficients. Typically, that is the term that we use. I prefer to call these m and c as weights. The reason being I call them weights, and it is applicable in deep learning because that is what the value that the input values get multiplied by with some amount of bias for you to provide that relation with the value y. So we discussed this aspect, and we also said in machine learning, having a relationship equation alone will not help the machine to learn. So there are two other equations that are relevant. Then we looked at once you initialize some bit of value to the m and c, that is the beta naught and beta 1, then you will go on to see what is the predicted value that we get, that is y hat we spoke about. Once you have some bit of initialization of m and c, you get some output. So initializer can be value 1. Once you get the output, compare against the actual output y minus y hat here, and that is called error between actual and predicted. We spoke about that. And then how do you rectify this error, minimize the error and bring it to near zero? So that's where we spoke about a third one, where it talks about how do I bring that error down, and we used gradient descent as an approach to talk about. While you don't need to use the third equation, there are some statistical methods like ordinary least square method, which will help us to computationally identify the best m value, best coefficients basically. We will look at that briefly too. However, my view is you please remember that broadly machine learning is driven by these three mathematical equations. In deep learning, of course, the first equation becomes very diverse. However, still these three are applicable broadly in deep learning too. Having said, we went and said, depending on what you want to identify, as an example, I will say, suppose if you are predicting what you are predicting is, let us say, that is the profit of a company, then it becomes a continuous value. Profit of a company, here I will write probably in a different color so we can see. Yeah. So profit of a company becomes, it is a continuous value. You have the numbers going on that comes under regression. And since profit is the target value, then you know that it is supervised learning. We spoke about unsupervised learning will not have the target value, the output that you want to predict. So this value you don't have, while only input values that you have in case of unsupervised learning. Well, supervised learning will have both of them. It has both the values, and that's how it is more guided learning. Now, if what you are predicting is something like whether there is diabetes or not, today we are going to probably look at some examples under regression. As I mentioned, what will be the house price if you want to buy a house in Hyderabad? What is the likely price of the house? That comes under regression value. Or we are going to look at another example. What is the likely insurance charge? So you want to apply for insurance and you want to know what is the estimated price of insurance that you got to buy. And let's say your family includes six people, where you have two children of a certain age and you have parents, and for all of them you have to cover insurance as an example. Then how much it costs? Insurance being the continuous value, it is the amount, so therefore it becomes continuous and supervised. On the other hand, if you are going to figure out whether there will be a let's say there will be a flight delay or not, or let's say will it rain tomorrow or not, will it rain, these are all binary classifications, and these are discrete values. You can have nominal, you can have ordinal values that could potentially come under that will all come under discrete values. In that case you use this. So we discussed this. Then we also said uh, the machine learning is different from software programs, and the essential difference that comes is based on here. If you notice the essential difference that we are getting, I will try and make it slightly bigger so that I'm hoping now it is legible. Yeah, this should be legible for you. Um, so if you notice here, normally software programs will have rules provided, while machine learning programs, rules are decided by the machine itself. Now, how it is happening is because we know that pattern recognition, there is a method in which we can recognize patterns. So we are teaching the model with that pattern recognition and all our three equations here. So all we are providing the machine is experiences. This is nothing but experiences, where you are showing a person, showing an object, and labeling, where you are saying so and so entity, what is the output that can have. Let's see. So this is how, or in this case here you are showing the area, location, all those details, and square feet and so on, and house price. So when you provide all of these inputs, that's how, if for example if you are from Hyderabad, you would know what is the likely price per square feet in, let us say, Amirpet, or the place we live in, Gachibowli. So or a rural or the outskirts of Hyderabad, it is not outskirt really, LB Nagar or Uppal. So you will be able to have some estimated price. How are you determining that estimated price? It is because you have seen the prices of different places either in the newspaper or somebody has told you. You used that information and guesstimated a sort of, it is not even really estimate, guesstimated, so that you are somewhere approximately you are coming there. Similarly, machine also will have the data and output to, and then it will generate those rules. This is a lot more objective than humans, and it is so objective that it is always accurate in terms of based on its experience. It will say at the time of training and testing, at the time of testing, this is the confidence level at which I am predicting for you, and it doesn't go wrong. If you provide more and more experiences, if you give say one 10 lakh houses data of all the locations of different locations in Hyderabad, and after that you ask the machine to predict, to estimate a new house size, it is more likely to give you near perfect answer. Of course, there are some other reasons why the house price can increase at that point in time too. However, machine is likely to be accurate. We spoke about this. In case you wonder why I am moving fast, because it is only a recap of what we learned yesterday. Now, you said artificial intelligence is a very broad thing where the machine has ability to learn and reason. All of those machines are called artificially intelligent machines. Now, the software robot nowadays you hear often something called robotic process automation, RPA. RPA is nothing but a software robot that is subsequently called softbot, and finally they said it is bot. So since I think 2011 or so, it is gaining a lot of popularity. Now these bots, which are many of them are rule based, where, for example, this is a company where 10,000 people are there, and if there is a problem with their laptop or connection, so then they approach a network administrator, IT administrator. Now you can have rules put in saying that what are different problems that one would get and how do we solve them. If you put all of that logic and rules together, and that is also artificially intelligent. It is solving problems, it is doing the troubleshooting, it is resolving the issues for the people, and therefore it is an intelligent machine. Now, those machines are different from machine learning, because in machine learning, you are not providing any rules beforehand. And it is learning by itself. That is the distinction with machine learning. Now, deep learning, the primary difference, I said, deep learning has a model which mimics human brain. So the network in the human brain. In the brain, you have different neurons, billions of neurons, and they are all interconnected extensively to. They're all interconnected. In the same way, deep learning also has such a networked connections, that a network of connections. That is because between input values and output values, we are introducing hidden layers. That's how machine learning and deep learning is different. Broadly, you can call all of them under machine learning, because all of them are learning from their experiences or learning from the input data. We looked at this, then we went ahead with what is the difference between the three, and finally we said data science solution life cycle is complex set of multitude of things. It involves software development, it involves user interface development, it involves back-end server side, it involves data management, it involves now machine learning model. Within the model, you got to process the data, prepare the data, gather the data. Now, even before you start any of these things, there has to be a domain expert who provides some inputs around what is the context in which the problem is, and somebody understands the problem, empathizes with it, and recognizes what are the input variables that have relevance on the target value or the output value. So we looked at it. We also said that being in the data science field, you can have opportunities in many areas. One is you can be a software programmer, network engineer, you can be a machine learning engineer, you can be a data engineer, which has more jobs. Data engineers, processing, gathering and processing data is very, very complex. Then you can be a data science consultant, domain expert, where you understand the education space, let us say, very well, and therefore you can be a domain expert. Those of you who have 15 years experience can understand, when SAP has come to India, it came in 90s. So mid 90s is where we had SAP coming to India. So mid 90s or late 90s. So it had implemented the enterprise level resource planning or enterprise level application, software application. Then whoever has been associated with it from the client side, they slowly joined SAP, who made the product much robust with the domain expertise, being an implementation consultant and so on. I am familiar because one of my jobs in the past, where some of the colleagues have supported the human resource module in SAP, and what I gathered was some of them even joined SAP subsequently. All right. So what I want to say is, even domain experts can continue to be there in the data science solution life cycle. It is not far away for those people too. And that's how we wrapped up the intro part. And we have then moved to Python programming. I will, at a very high level, at a very high level, I will try and talk about Python programming as well. so that you are familiar. Yesterday I shared how do you install and how do you open it. Now I am working on a Mac system, so I will get applications as icons. However, in your case, you will probably get on the left hand side. You click it and then you will have and then type Anaconda. What you will get is this Anaconda navigator. When you click the Anaconda navigator, you will open a window where you will see Jupyter over there. Now, yeah. So here you can launch the Jupyter. We spoke about it. Probably this window may be small. I'll try and keep it open. Yeah, Jupyter you can launch here. And I also said in the applications you can create a virtual environment for yourself. There is another way that I want to show you today is you can also go to your terminal, whichever is the terminal. For me, I will get a terminal like this. I have already Python Jupyter notebook running, which means I have a code running. I will close this just to explain you. I can close it by doing Control C. Yes. Now, all right. So the kernel is closed for the Jupyter notebook. And what I will now do, just allow me to increase the size of it. All right. Now, if you notice at the bottom, I have this model. I will still increase the size. On my at the bottom of the my terminal, you will notice Mauli MacBook Pro and Mauli, but you also see AI training because I am on that environment. I can deactivate the environment by typing this. However, currently on my machine, I am running all the packages on that environment which I created. So I will go and activate it. All right. Now, very simple here. All you have to do is type Jupyter notebook, and you have the notebook open. Now, along with it, you have the Python terminal is also running. You have the terminal running here and the Jupyter notebook open. So we will quickly look at what we did yesterday. Yeah, so we had looked at basic code of Python. I'm assuming those of you interested, you have done some bit of work of viewing. Somebody said not visible. I'm hoping it is visible. You are able to see the screen. Maybe you can use some earphones and listen. All right. So let us now go to the basic level command just to make sure that you remember. All right. So yesterday we saw this, and for the benefit of members who have not who missed out yesterday this piece or it was not visible, I'm hoping this is visible now. Now, if you notice the Jupyter notebook on the top, I said the default is localhost and 8888. You can always change the host to however you can leave that to the experts. The important aspect is you have file, edit, this is the menu. The required menu, you can always create with the plus button a line. And I said yesterday, this Jupyter has this advantage of line-wise execution. So you can easily execute by the lines, and you know if there is an error, you can immediately figure that out here. Now cut, your copy paste, you run the file. So I spoke about here if you have this thing of let's say, yeah, we will create one new value here saying that a is equal to 99 and print a. All I have to do is go and run and I get the value. Now it printed the value. Now what happens if you print and then keep the character, keep it in the string, you will get value a as an output because it has considered this as a character within it. This is the advantage I spoke about, where we don't have to define the data type within the Python. Now, very quickly, I will take you through. This is a print command, and there are integers, float is decimal, character and string for characters, and words, largely word. Otherwise, string can be any value inside. You can keep single quote or double quote or triple quote. A boolean is true, false here. Now you can print using a string inside. Two libraries which are extremely important I spoke about yesterday are NumPy for all the mathematical computations. Pandas has many advantages. I use Pandas primarily to create tables. Tables in Python is called data frames. Now this is an optional interactive shell as a let's say method here, function, where you can print all the values even in between using this particular lines of code, otherwise not relevant. So we spoke about then how do you do this computation, which is very close to English language computation. Whatever we are writing, a plus b, when both are integer or floats, it can add, but integer and string it can't do. String and string it can always append. We looked at this data yesterday. Then we looked at some bit of what are strings. Now, and manipulating the strings, you can append it, you can concatenate it, you can play around with it. How do you denote here strings? We spoke about it. You can delete a string like this with ease. Then we spoke about, you can assign the values to something and then call that value. So length of the string can be identified. Indexing, this is an important concept. You can identify, in this case of string, the index of the values, and index always starts from 0 in Python, which we need to remember. And if you use minus one starts from the right hand side of the value. So we discussed some of these aspects yesterday, and you will keep the values in square braces. And so on. So we discussed this part. I will see if there is any start stop step is something that you can practice by yourself. This is now we also looked at lists briefly, and that's where we stopped yesterday. And list, we spoke about collection, which is it is ordered and changeable. It allows duplicate members. Biggest advantage with list is you can have different data types within the list. That's where you have a lot more flexibility with it. So we spoke about here. You will notice it is a sequence and a collection of different data types. A sequence because you can index the values in it. It is mutable, which means you can modify the value. You will always store the values with a comma, which is again provided here. So items separated by commas is where you declare, and the list is created in square bracket. Till here we discussed yesterday, and I'm now moving to the areas that we want to talk about, and then probably somewhere during the day we will go through the rest of the aspects to here. All right, welcome to, yeah. Yeah. Today, you probably Vishnu would have shared with you, we are going to look at two different problems. One is predicting the house price. So we have an example of Boston. This Boston house price prediction data set is available in, it is available within the scikit-learn, I think scientific-learn. So I downloaded that from the model itself and kept it aside for you to see. And then we will also look at predicting the insurance charges. So, or medical insurance charges. If you want to apply for insurance, what kind of charges that can be levied. So these two topics we will discuss. The idea for this is to understand linear regression model. Predict insurance charges in a company in US, how much they levy, and estimate housing expenses in Boston area. Now, I will be navigating through different slides so that I have to share with you the data set. So for the insurance charges, what are the variables that will have an impact? So we know that typically for an insurance, some of the values that can have impact. What whatever occurs to me, I will share or some relevant aspects so that you can work on that too. So for insurance, one of the factors that is important is age of us. Age has an impact because the insurance charge can increase, insurance impact can be higher, the medical expenses can be higher for it. Second is the members in the family. If you have children, then the insurance can grow. Uh, then what other factors that can impact? Let us look at this particular data set to see. Yeah. All right, good. So I will try and make this bigger. You will have to until then wait. Otherwise, let me see. Now here we have patient ID, age of the person, and gender. Yeah, that's a good thing. Gender of person, body mass index, children, whether the person is smoker or not, which region the person belongs to, and what are the charges that the person is paying. So let's take a few examples from here and keep it on our machine so that we can continue to work from the same page. Let us say I will keep here in the next slide. I will create a new slide and post here our data set. This is our data set, some values of the data, and our, this is insurance. Now, what we have to predict is we have to predict these charges, estimate what can be the charges that we could have. And you can take example of something like you are a 32-year-old and you are a female and you have two children and you live at so and so location. Now what should be the charge? And that data is not readily available. Uh, yeah. So if I have to move away from this drawing, I'm just checking. Yeah. So here I'm hoping you are able to see the line. Otherwise, I will create this line for you as a table. Yeah, I think this should be better in terms of understanding. I'm glad we got this. Let me just keep it center so that it is more evident. I will once again repeat, we are attempting to estimate insurance charges for an unknown data value given the patient ID, age, gender, BMI, children, smoker, and whether the person is smoker or not, and the region. Now, the machine can understand only these numbers, right? Numbers here and numbers here, but it can't understand the text in as is form. This is a challenge that we have to address now. Now, before that, I will also try and keep what we call as X and what we call as Y. I'm sure by now you would have guessed X values are all which are input values. So for us, the input values are these things. These are all input values for us. You message there in case you are not able to see the screen size or anything here, and this is the output value. This is output. Okay, this is output value. Now, we typically call the output value is the y because this is what we want to get, and these are all x values. So, since there are 3, 6, 7 values, then it becomes more like x1, x2, and so on. Now, see the person, all these are attributes, you could say attributes of one patient. This is one patient, and this is the second patient, and the patient, first patient, if you look at the patient's age, that is not correct. It is not a patient really. It is about the individual that we are talking. So the first individual age is 19 years and gender is female. The person's body mass index is 27.9 and the children is 0 and the person is smoker. And the person location is southwest. In US we have different regions in US, you can broadly say, and don't charge me saying that this is not correct. I'm very broadly drawing it, and this is where Mexico, this is California, and yeah, this is where Phoenix and so on. So this is Florida, and yeah, there are these islands. However, is a broad thing. Now this is the east. This is northeast you can call, and this is the southeast you can call, and this is west side. This is northwest, and this is southwest. There are 4 regions. Broadly, it is grouped in. In reality, US have slightly different groups, which is fine, but our data set region is more about these 4 regions that we are talking. Now, these X values are there. Machine can understand only 1 or 2, while the other things it can't understand. There is one more problem here if you notice that it can understand only the age part because this is only continuous value. Yeah, and BMI, body mass index value, which is also continuous, and children also continuous. Smoker is a binary value. How does it understand? Gender is a binary value. How does it understand? Reason is a categorical value. How does it understand? Does patient ID really relevant to predict the charges? How much is the insurance charge be? Answer is no. So this is not relevant. So you also have some input variables which are irrelevant to estimate. A thumb rule to identify whether a particular value is relevant or not. So based on some inputs, we will also share with you these drawings or the class discussions. Like I said earlier, we will try and keep the mathematics to the least. However, there are some which we can't avoid. Now, what I want to say is there is a thumb rule to say whether a particular input variable will have any relevance to the output variable or not. That is, if if the if the values are all independent or mostly, or I'll put the words, if the values are all unique or mostly unique, then such variable will not may not have impact. Because if all the values of this row is different, then how can you bring the pattern using that? These are all very different. You will end up having those many unique values under the charges. You can't have any sort of grouping based on that. This is one. And two, if you have this is I think a primary aspect. And two, if most of them or all of them have same value, this is another problem. If then value is same throughout the variable, then it will not have much difference. Say, let's say the smoker is 100% of the cases, it is hypothetical. Say hypothetical, 100% of the cases there is no smoker. Then if it is 100% no, it can't have any influence because you are only dealing with no's. So these two cases, these are the two cases where these value become irrelevant. I would say irrelevant here. Now, the bigger question that I want to ask and then delve further is, we need to understand more about what are different data types and how do we make all those data types understandable by machine, which is where I will go into the next step now. I call that as, so I have some pointers here for us to look at. This is house price, or initially now we are talking about, we started with the insurance charges. So in the insurance charges, now we understood the context, we understood the need, saying we need to estimate how much is the insurance that we'll have to pay. We looked at what is X, there are X1 to X7, and we looked at what is Y, and we will come to which are those three equations. But important is, how does all X values can be understood by the machine? So this is called data pre-processing. Now we will go into the details of data pre-processing. Now, first question that we need to ask ourselves is what is data? So you have a set of attributes or variables, and then you have different objects or different records available. In this case, we are looking at, yeah, this term is very harsh cheat. It is whether a person repays or not. Let's say something like whether a person pays the tax, full tax or not, yes or no kind of thing we are looking at. And you are looking at whether a person is marital status, taxable income. Now each line here is, if you notice, is object. So an object or a record that we are talking about, I'll increase it further so that it can be probably legible. Yeah. Now, so each input here of one person data or one data object, it is called object. Now, these are, I call them as variables. I'm more comfortable calling them as variables. Some call it as attributes. This is what forms the table of variables and objects for us. So you have some example. An attribute is a property of an object. So if you look at these attributes here, for an individual person, is the person married or not? Did the person seek any refund? You will ask after you file the income tax, you might ask for refund if the deductions are high. And what was the total amount the person has paid? And I'm sure you are familiar with this language of 125K. Here K means 1000. K is a short form of, you can call it as kilogram kind of thing, where it is 1000. So 125,000, this is more given in the US dollars. So $125,000 is what they are talking about. Now, if you, we don't need to compute, let's say $100,000 at the rate of today, 75, 76 rupees, due to current situation, it is increasing. That is equivalent to some 76 lakh rupees at the end of the month, at the end of the year. That is the annual pay that we are talking about here for each record. Now, what happened for a person? These are different variables or different attributes. Each object has those values. Now, next, let us look at a little more and go further to see what are different data types and forms. And I will probably be little faster here as relevant. There are numerical data and there are categorical values. So in numericals, you can have continuous value. An example for continuous value, I think we have been talking, is the profit of in a company is continuous. Now, this is one example, or sales of a particular service, number of mangoes that are sold, that is a continuous value. Now, discrete values on the other hand, you have interval. Interval is the continuous and ratios. Discrete value on the other hand can be ordinal, which are like a ranking system. So you can say in an order. So that one person who scored highest in your subject, say 98 out of 100, if you still have this kind of marks mechanism in college, that person is a first rank, and somebody else 94 and second rank, and so on, and someone 93 third rank, and somebody 87 is fourth rank. Now you will also notice by now that the between rank 1 and rank 2, rank 2 and rank 3, and 3 and 4, the unit of magnitude is not same. They are different. Only the value here are 1, 2, 3, and 4, but inherently they are not same. So these are ordinal values. So we will go into little more details of time, periodic values, nominal values, and so on. Broadly, you have continuous and discrete or categorical. So you have to work on these values to make machine to understand. Machine can only understand at the moment continuous values. Of course, yeah, continuous values only machine will understand directly. Now, is there a taxonomy, a sort of a dictionary for what are different data types? If you search in internet, you will realize that so many people have claimed different set as data types, and I am one of them, I would say, where I have also gathered some information and viewed that these terms can be broadly or different types of data to deal with. I have the details of it. You notice I also kept not relevant as a type of data, which so that you don't use this data for any predictions. I spoke about, we just saw the patient ID or the citizen ID. It is like our Aadhaar card. Now, does Aadhaar card number decide what should be the what can be the estimate of our insurance charge? Or our driving license number, can it decide? Or the roll number of a student in the class, can that decide whether the student will fare well or not in the class, whether the student will succeed in the life or not? It can't. So these are all the data types, I would say they are not relevant. So it is another thing that yeah, there are certain values which are not relevant, and things like serial number, roll number, and employee IDs, and so on. Now we will see the what are nominal binary values. It is very clear, ordinary values. I will talk at a high level each one of this. Probably please pay some attention to see this, and then we will take a break. Now, nominal values are discrete values. They don't have any numerical relationship. So I said that while you have the ranks available, or ranks can be ordinal values. Nominal values, one example here I can say is the person nationality of a person. One person is an Indian, or somebody is American, someone is Asian, someone is Europeans. Now, if you have the data like this, you cannot have, so even if you keep 1, 2, 3, 4 there, there is no mean value for it. You can't have, okay, I am looking at India and US, so therefore I will do the mean, and probably I'll pick up something at the center. If I have to go by flight, the center comes normally is Europe, so I will go for Europe as the mean value. You can't do that. So in the nominal values, you can't do. Now, you can do one hot encoding. We will talk about what is one hot encoding, this entire encoding of data to convert nominal values into ones and zeros. We will talk about that. Now, ordinal values are again, these are discrete integers, and we took one example of being on the class first rank, second rank, third rank in the class. And these are, while they appear like numbers, they are numericals, they are numbers, but then again, we cannot have the magnitude is not same. So we have to again convert this into some sort of one hot encoding. I will talk about. We have to encode this as we progress. There is more to understand in this area. Then binary values. Binary is 1 and 0. You will notice here yes or no and 1 and 0. This you can go ahead and use any binary value. You can just use 1 or 0 and this is sufficient. So both 1 and 0 can be understood by the machine, and these are two different. So if you are doing a logistic regression, or let's say the person gender, you have gender both female and male, you convert them female values into 1 and male values into 0, and ones and zeros can be understood by the machine, and you can always distinguish. Next is time. It is super complex. However, pandas have a mechanism to capture this data because every value in the time has a reference, date, day, month, week, annual, etc. This is a unique data type. Continuous values, interval and ratios, I broadly combine and say these are continuous values, which is something the machine can understand easily. There are already at a kernel level, the machine has the code. So anything that you write with a continuous value, it understands. This is the best thing that we can have as an input value. Now, while you saw there are different types of data available, how do we process this data? Uh, the first step in processing data is you have to fill in missing values, smooth noisy data, identify or remove outliers. Now, today the table that you are seeing here, it is very straightforward data. You can easily look at what is the patient ID, age, gender, BMI. However, imagine yesterday I was referring to one example of GE gas turbine, General Electric gas turbine, and it provides you continuous stream of data. We spoke about another example of surveillance camera in highly populous areas, say temples or any religious places and very busy markets. You have, let's say, surveillance cameras are kept. Now there the data is a continuous stream of videos, right? That video data has to be continuous stream. It can have, let's say, 20 frames or 30 frames per second. You say when you are taking pictures, you talk about how many frames are there per second for your picture. Now the video has to be converted into frames. Each frame has something, and from there you have to finally get the facial features and so on and so forth. These are facial features of the person, and from there you will finally get some sort of numbers. Tomorrow we will talk about how do you tomorrow or day after tomorrow we will convert all the facial features into some sort of numbers for machine to understand. Now this entire process is cleaning process. Some bit of noise you have to remove, the background, somebody here and there. Every frame you want to segregate people, object detection you have to do, and only people have to be separated. This is a lot of tasks. That is what data cleaning is largely. Of course, missing values, we will check if in our data set, if there are missing values, then we will see uh, how to fill those missing values, or should we just remove the record completely? If you keep removing records, sometimes in a healthcare set surveys which is applicable for kids, elderly people, all genders, there will be many blank fields, and if you start removing blank fields, you may not have any record with all the data. So therefore removing the record when there is a missing value is the last thing one could do. We have to imputation, we say you fill it with some reasonable value, and we talk about how do you do that. Then we see data integration. Sometimes you will get data if in case of surveillance cameras, you have, let's say, 20 hot spots where people could congregate, and then there is a high chance of certain wrong things that could happen. So you have to put together all of that inputs together and then start analyzing. That is integration of multiple databases. Normalization, aggregation. So when you have, for example, in our data set also, you have data from different formats. So you have some BMI value to be on this side, and age can really swing in big numbers, while children is very small. It can be 0 or 1 or 2 or 3. Maximum is 3. Now, if you have to compare children with the age, there is this disparity. So it is better that you bring all the values to some sort of a normalized standard normal distribution we call, where you make the mean value for each of these variables to 0. So you bring we will look into little more details as we go. So where you bring the mean value as 0, so that your distribution, assuming that typically the data falls in the normal distribution format. So the machine learning has a lot of assumptions, by the way, which is also helping deep learning to flourish well, because for machine learning to work, your expectation is data falls under normal distribution, where you keep the mu being at mean being 0 and so on, standard normal distribution. You transform the data, this is a better one. Data reduction, it is if you have large amount of data, how do you bring that down and compress that to a smaller chunk, which is a good representation of the overall data. For example, if you look at during the elections, in the elections period, you have the likelihood of majority for, let's say, BJP and Congress. Now, I keep hearing BJP as a winning party in many states now. Of course, there are many regional parties like our Telangana, Andhra Pradesh, we have regional parties. Many states we have regional parties too. Now, in the elections, how do we estimate who is getting majority? Are they going and talking to every citizen, every eligible voter? No, they are only picking up a representative sample. So using stratified, they say, so they will go and check people with different age group is one stratification. People with different professions, another stratification. People with yeah, this is interesting. All the regions, third stratification. If you look at last elections in US, there is this huge amount of support to Hillary Clinton, that she is a candidate for presidential election, so she is the likely winner. So Hillary Clinton had so much of a majority, and then subsequent analysis indicated that they have missed out on certain professions, because the people whom they approached did not have all the professions included there. They also missed out, they underestimated the kind of majority Hillary Clinton has somewhere in the western side, south, central west, or towards western side. They did not do much of analysis of that region, which gave that huge edge to Donald Trump. So these were the errors that they do. So you have to be extremely careful. One has to be extremely careful while sampling, while data reduction is the answer to understand how do we quickly process and see some insights from the data. Yeah, data discretization, so we can make it discrete. So if you look at many of the data sets that we are going to show you these 4 days, all of them are from the public domain. We are not sharing with you our product related data. So how do we convert entire thing which is very discrete, which is not appearing, and more towards data discretization is there, which we need not understand right now. However, the other aspects are definitely relevant. We will take 5 minutes break. Once we come back from the break, I will quickly go through the questions that have come. I will spend up to 10 minutes. I'll try my best to answer those questions, and we will resume the remaining reminder session. బ్రేక్ వచ్చేసింది వాల్యూమ్ పెట్టి చూడండి. many questions. So, regression analysis. Because in the Bluetooth sometimes it can appear. All right, let us look at some bit of the Q&A that are coming. I hope you will not mind. I picked up a cup of tea for myself, and given the time challenge, I decided to start looking at the questions quickly. Any example of data discretization I will share. Attendance sheet. Thank you so much for many comments. My request is to the extent possible, they avoid this so that I will get to see the questions only. Is processing essential for all data sets? So there's a question, is pre-processing essential for all data sets? Answer is yes. You have to process the data and push numerical values and vector form. We will discuss what is the format in which you can share the data. Anomaly detection and where is it applied in data processing. We will look at anomalies soon. Please share data set. So we will share it just after the class. Yesterday there was a delay because of my logistics. Today you will not have any delay. Outliers means, so when you have data where you expect them to fall in a pattern in the normal distribution, so you have some data which is very far flung on the right side or left side. Let us say we are talking about age of people. So age, typically have you have outliers on the right hand side, age of people who goes to work, and this age is anywhere between 18 years to 70 years is the age of the people typically who goes to work. And you have some outliers who at the age of 94, 95, and 102, you have some people going to work. So that 100 to 104 becomes an outlier who is going to work. Similarly, you have this child labor. Somebody at the age of 8 years is going to work. So these are outliers. You have, so sorry, ma'am, somebody just joined the set little while ago. I think I met Miss Fatima, the professor at Stanley, in one of the meetings. Good. All right. So these are some questions that I could see. Because of the comments, I'm not able to get it. Yeah, please stop chatting. I'm realizing that even though we keep a break screen or video, you are still hearing the chatting noise. Just due to data reduction in some specific information may get lost means what we do. Yeah, data reduction, you have to be one has to be very prudent about which method do you use for data reduction. You have to take a right sample, take stratified sample and test whether it is giving or not. One. Two, we also do data transformation. We have something called as dimensionality reduction, where if you have, let's say, 1100 variables, I worked on one data set where there are 1100 variables. I had to reduce the number of dimensions, otherwise I will have too many coefficients. We will have to carefully identify a method to do. All right. So I could only gather this, and probably I missed some pointers because of different messages. Video for future reference. You have a video available in YouTube all the time. Image processing data, you will definitely see the image processing data day after tomorrow. We will have uh, handling video and audio data, we will avoid because audio data is a subject by itself. You need to go through how we break into 1/20th of a hedge, 1/20th of a second as one data variable, one data point, and that's how we feed the machine to identify the characters of it. It is complex. Handling video also is, we have to handle the video stream into frames per second and convert. Can we link the big data to AI? Now, the first question is, what is big data? Data which is unstructured. It is like in your chat script. Now you are writing these so many comments. Can we create a table out of it? It takes a lot of efforts. And imagine in a day, all the people who have chatted. If we put all of that together, we can't create a table with a primary key, secondary key, and so on. So such data is called big data. Yes, we have text analysis through which we can work with AI. We can connect to AI and then draw insights from it, predict things, text, images, numbers. We can do that. It's possible. What is dimensionality reduction? Or does dimensionality reduction mean to reduce the similar type features? Yeah, so the features need not be similar. It is a combination of the features you convert and transform them into lesser number of features, and yet you make sure that you have the data available, representation of the data. Imagine that you have 10 input variables and you are predicting one output variable, right? And the same output is more like or two output variables you will predict from these 10, and that becomes an input further to analyze. So I'm hoping Ms. Arya, it answers. When can we use regression or classification or clustering? What kind of data supports for the above method? Yeah, I will answer this. I will just take one more minute break before I'll get back to the main live screen. All right, welcome back. One of the things that I figured out was when we go on break or we go and break a pause in the starting time, you hear this charting that is having at my end. I got to know how to reduce that piece now. Just one moment. All right, let's come back. I have some information for all of you from Ms. Anuradha, who is the founder of Black Buck Engineers. She writes, she suggested, please don't post other information than the FDP related data. Important announcements will be lost for serious learners. Yeah, this is an excellent effort that's been put up by Blackbuck engineers and CMR College. Please use that post only for the relevant data. Thank you for the feedback. This is what encourages us to do better. We'll take into consideration suggestions given by you. Definitely, to the extent possible, we will incorporate that. Don't worry about attendance. Please, please fill the feedback form by 2 p.m. We've got a number of inquiries for centers of excellence. There are lots of activities coming up, more faculty development programs and industry speakers and hiring from our centers of excellence. In case you are not familiar with the centers of excellence, this is a great initiative where Blackbuck engineers set up some sort of a virtual organization within your campus, a center of excellence where they promote the artificial intelligence, machine learning, and deep learning learning courses. They also provide a parallel postgraduate diploma to the students. And I view in the current environment, we got to be, it's extremely important for all of us to be deep generalists. Not sure academically we use this term. We are always familiar with a specialist, someone who knows their subject so well, and then generalists. Generalists are someone who have knowledge of different areas and they move in managerial cadre. So typically academicians will be specialists because you know your subject very thoroughly. You understand adult learning principles extremely well. That's how you are able to train those students. Now, deep generalist talks about how can I have a deep expertise in more than one area. There are two areas if I have, then my marketability, my net worth, my ability to contribute to society will be higher. So increasingly with automation, a lot of jobs might go away. So if you notice 30 years ago to today, there are no clerical jobs, there are not many assistant jobs, so they are going away. Now, in future, even driver's need will go away. So we pay a decent amount to the driver. So the driver salaries also will not be there, and drivers are not required as we progress because of automated vehicles. As an example, even some of our professional areas also might fade away. In case of deep generalist, their net worth and their requirement will be high because they understand more than one area. Imagine you not only understand your subject. I saw one of the professors is into mathematics. So you not only are aware of mathematics, you also understand how to manage the students or how to place the students, how to market the students' value to the corporate world, business world. Then you have two different knowledges, two different areas of knowledge. Similarly, for engineering students, if they gain specialization in, let's say, mechanical engineering or electronics engineering, better at computer science or information systems, they also have a good understanding of machine learning models, deep learning models. So they have one aspect of web development, another aspect of machine learning models. So this will help them become deep generalists over time. So it requires a good amount of expertise, and I think that way Blackbuck Engineers is doing a tremendous work. She says we won't spam you, we will just send a mailer to you for professors and directors who expressed interest, whoever have interest for them. Only if you respond, we will get back to you. That is appreciative of them. Happy learning once again. All right, we will get back to our work. We were last time at which place? Sorry. Yeah, we are at this place. I will try and expedite our discussion and I'll try and answer other questions. Why data processing? We spoke about, yeah, this word may be harsh. However, the data is in different formats. It is not clean. You have occupation being blank, salary is -10. So you have to clean this. Without pre-processing data, if you try and push it into the model, it will not give you an output. So first of all, it can't even recognize the complex ratings, different values, etc. You need to clean the data and prepare it. These are all good to know. A well accepted multi-dimensional view. Data has to be accurate. So all the values in the table should be accurate. It's complete, consistent. Yeah, timeliness is good. Believability. These are some attributes you can refer to. Now, I have a couple of important aspects I want to touch before we go. We discussed these things, so I am not going into details. Missing data, there are many ways you deal with the missing values. One, you can remove the record. Two, depending on if mean is a right thing, you can fill it with the mean value or model value, whichever is the right one, or frequently occurring value, and so on. You can work with the missing data. You can even have unknown as a class, new class, where it will remain as a pretty much like a blank unknown, so that you are not creating bias to the data. Data transformation, we spoke about some of these things under data transformation. Yeah, there were questions around how do you reduce the data. I suggested that the representative sample has to be taken when you are compressing, reducing the data. Dimensionality reduction, I did talk about principal component analysis. Basically, it transforms the input variables. If you have 10 columns, it transforms all 10 and results in something like 2 columns. So if you have 50 columns, but the way it does is very complex. So it will take some bits of the column 1, some bits of column 2, some bits of column 3, and then quashes everything into one column like that. So it is representative, but we can't interpret what is the transformed new feature. It is just a gist of it. We can't really interpret the combination. Data compression, yeah, there are ways that you can do in terms of data compression. I will not go into details here. Types of sampling you have. I will try and share many of these slides with you so that you can use them as reference. We don't need this level of details. One question that somebody had, if I can show that. Okay, I'm not highlighting much at this stage the other aspects. Now let's go back. We now know how to process the data. We are good with it. And then what is the next step? We have processed the data. Somebody asked, can we do the code part? How do we process the data in the code? Let us run this particular file by ourselves, and then parallelly we will do both code as well as the learning part of the model. We are talking about the insurance charges, and I already have the file fully created, but then for your sake, I'm going to create and try and follow me. We will see what is the best way to do. I'm now creating a new file. I'll open a new file, new Python file we have opened. And here, initially for me to work with the data, for me to read the values and all, I have to take some libraries. Libraries are important, and I will explain what these libraries are. Import OS I will avoid, and let's see. Import NumPy so that my computation is possible. Import Pandas so that the CSV file that I am giving, I can interpret. These are other aspects. Import warnings, let's say I don't use any of it, and then I will go ahead and import these two libraries on my machine. Then I will call my data set. I will run my data set. So here, since I have my file in the same folder as that of, I will create this file. I can change the title here to this is my insurance practice on today is let's say um, I'm looking for the date 19/5/20. Yeah, this is what it is. I renamed, and you will notice in my system you have this file is where insurance practice file and insurance CSV file both are in the same folder. The folder is insurance charges. When I have this, I can simply call my value as this. Now, what I had done here is I'm calling pandas. Pandas has this particular method called read underscore CSV. CSV means comma separated values. That is the file that we saw. This is the CSV, and we will open it with Excel here. I will. So this is what we have been observing, right? This is comma separated value. You can have tab separated value also. TSV as well you can do. Now, in this, I am just calling that file name and it has come. Or without R also you can do it. This is not a problem. Sometimes if it doesn't work, it is a concern. That's all. So very simple. I have now brought my this CSV file into a data frame, and the name of the data frame is data. Data frame is nothing but a table, which is there in pandas. What I am now going to do is let me understand what does this data comprise of. So there is this syntax called head, which will give me, yeah, this is I'm supposed to call the head is a method in data frame. So I'm supposed to call like this. All right. So this is the method. When I call, I will get to see the top 5 values of my data set. So I'm able to see you have the patient ID, age, gender, BMI, and so on. Now, the next step that I have to do is, look, there are patient ID column is not relevant for me. I have to work on it. I have to change the gender, change the reason, maybe even change the children, because this can't be a continuous value. So let us see what are the changes that we can do. You can also, of course, you can also look at, this is an interesting aspect. You can see what are different data types that Python has recognized as. So there are some integers, we have object. So float is good, we can go ahead with. Integer is good. Objects have to be altered if you have to alter. So I will also not, you can do data describe, so it will give you the count, mean, standard deviation, all these values based on requirement. Again, this is not what we need. We are trying to simply put, can we convert all this, pre-process the data? That is the step we are working in the code. So I will not use any of it. Yeah, this is a good one. So can we see what are the missing values that are there? So whenever I use hash, then missing value. So that is a comment in this programming language. So there are no missing values in the first column, but there are missing values in age, missing values in gender, and so on. So you could either impute, you could, or you could even remove those if the number of missing values are fewer. For time's sake, we will try and do it faster. Um, Yeah. So here I have used treat missing values. I will drop all the NA values. So I'll drop all the non-applicable values. So this is one way. So it has dropped all of them. Then I can check are there any null values. So then I also want to remove the first column because so there are no more null values here. Once I do drop NA is a method again in this data frame where when if NA any blank value is called as NA, if that value is true, then you have to drop them. So those records will go away. And now you can also see the information by. So here we have number of entries here and 1324 entries here. But if you really go and check here how many entries, you will realize that so here I'm trying to clarify to you here. When I do data info, it will provide me information of what are different data types, and you will see here there are 1338 entries. You notice this 1338 entries. Now after removing the missing values, which are 5, 6, 9, 10, 13, but 13 may not be independent, some of the values have removed, and therefore you got 1324 um, values only are left. So that's how I have created this, to show you that how it removed, that missing values are removed from it. Let us now go to, there is one column which is not relevant for us, patient ID. It can't add any value because these are all independent. So we will remove, drop unwanted values here. So I will drop unwanted values. So those of you who do not want to do coding, you don't have to, you please just watch what is happening, but it is not essential for all of us to be good with coding, even to learn coding, not essential, I would say. Now I dropped, after this if you check the head, let's say what are the data, what is the data available, you will realize that the first column is gone. It is not there. Now that we have removed this, let us now go and change the um, non-continuous values. We will change, convert categorical columns into numerical. I will copy all of it and run here. And before I talk about what I am doing here, I'm basically using a label encoder. But for us to know what is a label encoder, I have to tell you that the bigger question that we have to ask is, all right, you figured out that data processing has to be done. Now we have put together, we are talking about right now is medical insurance. Yeah, we're talking about medical insurance. We understood pre-processing has to be done. We listed all input values. We identified if they are important, and we realized that patient ID column is not important, so we dropped. We listed important continuous values, no problem. There are categorical values now. How do we process them? The way to process is we have to use encoders. Now, encoding, I will try and share it again. High speed probably will do the encoding. Encoding, I have put together on document. Yeah. All right. So this is another colleague who's adopted and put this together. So you will see a template being different. Um, why do we need to encode the input? Because machine learning models need numbers, while humans, we can understand even classes. We need classes. In fact, bananas, apples, fish, these are all different types. So these are all there. So we looked at different types of data. I told you different people have ways to keep it, and she writes these are the different data types, but these are all different ways of presenting the data type. It is not important right now. What we want to know right now is what do I mean by encoding and how do I do it? So encoding can be transforming input data into something which is um, into something that machine can understand. So that is called an encoding. You will call it as one hot encoding when you have both ones and zeros present in every record. So when you are converting from numerical to categorical, from regression to classification. So if you want to classify whether a person has diabetes or not, and you have the data of little diabetes, means early signals, and then mature signals, and then early and signs of diabetes, and medium diabetes, and high diabetes, and very serious which can clot blood and then collapse, very serious diabetes. You have 6 different classes. Now you have to convert, and you have 1 2 3 4 5 6, and you have to put that into some sort of 0 and 1. You have to convert. Then there can be another numerical which has to be converted into categorical. Categorical to numerical, which is what we are now trying to work on. And there are many reasons why you do encoding. Now, preserving information distance is important. However, let us see how we do that. Now, single value encoding is each value is converted into a single integer number. This is again you will have one value. It is useful for ordinal and categorical variables. It is also useful for strings. So you can change the cat and the dog, each of these words, into some sort of a single value, 1 2 3 4 5. But these are not again these do not have same unit of magnitude. We have just converted into one single value. But finally, what we need to learn is one hot encoding, which I will quickly go there. Vectorization is what we will do. This also is complex right now. We will move from here. Yeah, one hot encoding is what we will do. Let's say a list of all different values is used as a sorted dictionary. Each value is encoded into an array of length. Now, I will see if you have an example. Now, there are gender male, female, and you also have not specified. So there are basically in this case, this as an example, we have now this is categorical. And in this categorical, you have totally three different values. So you have value 1, value 2, unique values. There's male, female, and not specified. And the next one is same as not specified, and female is same as the 2. All right. Now, how do I convert this categorical? It is categorical. It's not just binary. Categorical into some sort of machine understandable. That is our requirement right now. How do we make it machine understandable? The way one-hot encoding does is that it converts every unique value into one column. So male became one column, and female became another column. Column is nothing but one extra variable. So extra variable 1, variable 2, and variable 3. Now here, because there are three different unique values in a particular in one variable, this one variable is transformed into three different variables. This is what has happened. And then each now you have so of course later you have the male being mentioned in a particular way. So you have 1 0 0. So this is what will happen. And no, yeah, this is what happened. 1 0 0. This is the value. Now next time where you have wherever the male is, all those three variables will have a combination of 1 0 0. This way what you brought is distinction between each of them. And then so there is a distinction between male and not specified, distinction between male and female, distinction between female and specified. You bring those distinctions because these three combinations of numbers appear different. This is what we call one hot encoding, and we use this method. Of course, you can also, if you have to go in advanced level, so you can even convert into just encoding and say you could even keep it as 1 0 0 1 and 0 0. You can drop the last line too and have just two variables, because this also brings uniqueness into data. So that is also possible. However, that is at an advanced level, and I don't want to go into further details about it, except for you have dense and sparse values here. And one page that I will show, which is important for us to remember, is the right encoding can help your model learn better. They are not just about transformations. They can even provide extra details. We call it like that. We will now go back. So how do we now process that? Now that we understood we have to do some bit of encoding, let us go and do the encoding here on the code. All right. So sklearn is a scientific kit learn. This is a must to to go to in the if you are learning Python course for machine learning. So scikit-learn is what the package is. I will make it bigger. Yeah. So this is what the library has immense numbers of algorithms, functions and methods and objects being created. So we are going to extensively use their data. Now in sklearn, there is something called pre-processing, a set of cluster of functions. In that you have a method called label encoder. Now you want to understand more about label encoder, so you will see label encoder method is this. Now the way you can go and do is go to the scikit-learn and say, I want to know more about what is label encoder and what kind of parameters that I can pass. So you have to pass the arguments if at all. Particularly in our regression, we will be passing the arguments to label encoder. Yeah, this is sklearn.preprocessing.label encoder. So you can you have these more details that you have. You can pre-processing.label encoder. You can call it. However, in our case, sklearn.import.preprocessing, and then we just imported only label encoder. So this is where they will provide you an example and explanation to do. We will quickly go and work on our own things. We know that we need to work on. Let's say we will do one by one. Here we will remove the. So first one that I'm working is gender is there. I want to drop the fit and drop duplicates and transform them. So then a new data.gender, I will get a transformed data. So what I have done is first I imported label encoder here on this file, and then I am passing the data of label encoder into an object called LE, so that even if I modify, make any amendments to it, it will not affect my label encoder, and it is also smaller to fill. Then I'm calling within this, there is another method called fit. So what it can do is, so I am calling their gender. Gender is one attribute in the data, right? Data is where my data frame is sitting. In that, I can do drop duplicate so that I will only have unique values, and those unique values then I will transform and then replace the transformed data into the data.gender. Now after this, if you go and check, you will have new set of values that appear here. Let's say that I will do, I have an error. Argument must be a string or number. I will check where the error is coming to. Yeah. So let me make this change here. You are probably looking at it. Say, all right, I need to run the value first. So let me quickly run from the beginning so that I will have the error going up. All right. Now, because I did not run this particular data before, it's not been running. Now I got that error. Now I transformed the gender. I also have to transform other values. What are the gender has done? I will transform smoker and region too. So I will do it now, whether smoker or not. Again, I will use the same concept. So I will keep all of them separately. Smoker also drop duplicates, and I will get only unique values of yes or no, and that I will transform the data. Done. Now finally I will do the same thing for the region also. Region will have 4 values. I will do this. Now if I do let's say data.head, what you will get to see is, now you see suddenly all are transformed. You have zeros and ones here, and then smoker 1 0, and label encoder inherently takes care and it only shows us the value here. The region on the other hand is kept as 1 2 3. Now you have prepared the data. I'm hoping we are able to go together on this. We prepare the data and then let us see what we need to do. Of course, we have to do the missing values. We already did it. We removed the missing values. Now, all variables have, I will quickly change the title because we are first looking at the medical insurance as an example. All right. Now, in the next one, we have now come up with, we have completed our data is ready. Now, what do we do with it? We have all of it is ready. We have to now push this into our equations. Now, charges, we know these are continuous values with the decimal. So I can use I can start now applying my equations. I said about we have option of using we have to use three equations. First equation is about pattern identification. What is pattern identification? We will look at. And the second equation we spoke about error determination. How do we get the error? And third is error optimization. How do I optimize the error? Now, in the pattern identification, since it is a supervised learning continuous value, we will use the linear regression model. So I'm going to delve into linear regression model. And then in the error determination, we will use mean square error. So yesterday somebody asked why you are choosing mean square error. Now, one way to do is look, you use assuming, let's say y is in our example case. Where is our example case? Yeah, I find. In the example, these are all x1 values and this is y1 value, y value. Let us paste the new data from here. If I can copy it, I will do it. And I'm going to paste this value along with what we are doing here. I will keep it. Now, oh man, I want to paste this data that I have is as a special value unformatted. Okay, and let's see. Excellent, we have got the data. So this is what is the transformed value we have got, and now this we will try and where is the table lines? All right, this is transformed data set. Data set or corpus, these are different values that we can use. Okay, this is shifted slightly, but I will. What was the first value that we had in the case? Oh, this is only index. This is index, so we don't need index. In our case, delete the index. The position of a particular object or a row. And we will also clean a little more so that you will get to see everything clearly. All right, this is our data set and I'm hoping it is all eligible for you. Okay, now everything is in numbers. We can work on the numbers easily. For this, since these are all, this is a continuous value and these are all input variables, we will call these as x1, x2, x3, and let us I'm hoping you have some memory of linear regression. While we will go into details, x2, x3, x4, x5, and x6. Now, let's say this is value y, the equation that linear regression equation, where pattern relationship is, correlation is y is equal to mx plus c. I will call mx plus c as mx plus c only. Now, x here is 6 values, so invariably this becomes m1 x1, and then you have to get same thing, right? You will have so on, so forth, and so on, and then you have m6 x6 and plus a constant value or a bias value. This is the y value. Now, I said when you are applying this equation initially, let's say you are training the model. This is another important thing. For you to train the model, you have to first separate your data set into training data set and test data set. We will talk about that after some time, maybe around 12:15 or so, because I want to go into details of this model. Let's say you want to train and you have taken the first value, and initially you keep M and C as some random initializer. Let's say you keep 1 as a number. Then what happens with this value is you quickly compute 19 into 1 plus 0 into 1 plus 27.9 into 1 plus 0 into 1 plus smoker into 1 into 1, 3 into 1. So the value is roughly 23, 20, 40, 50, 50.9. Now constant also, let's take you to 1. This has one value, this has 1. Now the value that you predicted y hat from this first line, y hat has become, if you compute, you will, I forget again, 20, 30, 50, 50.9. The y hat is 50.9. What is the actual y value? Y value you see 16,884. Now what is the error that we have got? Error we have received is y minus y hat. The error is significantly high. It is 16,884 minus 15, which is 16,834, because 0.9 and 0.9 are there. This is the error that we are talking about. This is the error if we are doing a single value computation. Now, let's say just one value we will take, and now you have to reduce this error to minimum is 0. So we have to bring it, error lowest value is 0. How do you get it? So I said you are using the third equation, which is I spoke about more like a error gradient descent. So it is like this. You have the error value is right now very high, which is 16,000. Now you have to bring it to some minimum value of error. So you can follow the steps of some derivative. Now I have to use some sort of a derivatives of m for a given error, dE divided by derivative of the m, and I have to do derivative of error given given the constant value. We will do that in a more simplistic form by looking at understanding a little more about what is linear regression. So I will go into that details now, and just give me a minute for me to introduce you that. Linear regression. All right, now I have to have, yeah. So the model that we say linear regression, we don't need to go into the definitions, etc. Is yeah. So in the regression analysis, of course, error also we don't have to go into so much theory. We will straight away come back to our model. Yeah, before I go and explain you about more details of the current discussion where we are talking about how do we get this error reduced. This method is called stochastic gradient descent method. We are using stochastic is each object or each record you are looking at independently for error computation. Gradient descent is error. If the error value is this much, let's say I will create one more for the stochastic gradient descent, and after the break we'll speak more about the gradient descent. It is like this. In the gradient descent you have, let's say this is the error value, and at the moment I assume, yeah, I will put it slightly differently. Let's say if this is the error, this is the error value, error, and you are, it can be there, this is positive and this is negative value, and you can have an error like this. So where so this is let's say 20,000 right now, 20,000, and this being 0, and you have an error at 16,000, something like this, 16,800. So this error is roughly here. Now, we are talking like in gradient descent, you have the error has to be reduced. Let's say this is the error. This is where our current uh, coefficients are m and c resulted in an error of this much. The current coefficients were 1 and 1. We have taken that initializers. So when you have this, you have to reduce the error rate by some sort of a learning rate, we call it as, using, you can always use some sort of a curve and say this theta value, you bring it so that you can bring down the error to some extent. So this is more like a gradient, right? So this curve is a gradient, and therefore you are descending that gradient. That's how this term is called gradient descent. And slowly you bring it down, and you bring it down, the error rate, and bring it down. And there is a point where this is lowest. The error rate is lowest, and maybe this is the lowest sum, whichever is the error rate lowest. And after that, it is again increasing, the error is increasing. So the model should identify at a lowest error rate and say now stop. Whatever is the coefficients at that point, let's say the coefficients are, just as an example, we can always check the coefficient 30. This is 238, something like that only as there, I don't remember. Then the coefficient here is, let's say, 1400, and you use this, then you get a right value as a response. Of course, for us, it is not just m alone. We have m1 to m6. We have 6 coefficients we will get for our model. So we will compute all the coefficients, we'll get every value, and I'm assuming you are following through. This is the coefficient, right? Initially we have assumed everything as 1, and that's how we have got this 50.9. So 1 into 19, 1 into 0, 1 into 27, like that we have done to get y hat. Then you have done y minus y hat. So you got error of 16,000. I'll just hold myself. These are numbers, and I'm trying to see how is the best way for us to appreciate the model, and hoping that some bit of introduction you would have on the linear regression. These are the assumptions I made. There are professors in computer science, mathematics, and I'm sure you deal with the numbers day in and day out, and I'm sure you understand them thoroughly. For others, it is a cautionary thing. I'll have to work with the numbers to clarify. Now, we got this y hat value, which is 50.9, based on the assumption initializers of M1 to M6. And after putting through the gradient descent using some learning rate, it will come down, and the actual M1 to M6 values are known. So new M1 value is something, new M2 is something else, and finally the constant value is also something else. So these are called coefficients in statistics. If you recall coefficients, I wish to call them as weights. In the beginning of today's class, I spoke about it. I call these as weights because they are getting multiplied to my values in the data set, which is giving me some sort of a pattern to predict what is the charge that will be levied on me. This is what is happening for me. I will move to our linear regression model. Before I go into that place, someone asked this question, y is equal to mx plus c is for linear regression if what I am to predict is, let us say, is not a continuous value, it is a discrete value, something like a binary prediction. Now, if you have to do the binary prediction, I will create a new table for us so that it is easier. So let's say this is the data, and you want to know whether this person will have is susceptible to cancer or not. Let's say cancer. So what disease can come using smoking? Lung cancer can come. yeah, lung cancer or just cancer we will keep. This is yes or no. This is hypothetical, and say this is yes or no is converted into ones and zeros, one and zeros and so on, and zero. Now let's say this is what the data is that we are dealing with. Now in this case, our model of y is equal to mx plus c cannot work directly in this. The f of x that we are doing is assuming that y value has a minus infinity to infinity as the value. Now you have to quash this value from minus infinity to infinity to uh, 0 to 1, because that is what the cancer has, only 0 to 1 values we have. Now to transform this value you can do using odds ratio. If you remember odds ratio, you can do odds ratio is talks about probability of occurrence minus divided by 1 minus probability of occurrence. You put this data into this format and keep this as mx plus c, or beta naught, beta 1x plus beta naught. So the data will result in the probability of occurrence y is equal to, this is the probability of occurrence rate. Suddenly probability of occurrence is 0 and probability of occurrence 1. This is we can compute, and this comes to 1 by 1 plus e to the power of minus that mx plus c. So this is the value it gets transformed. You use a logit function, and therefore this is the result. So if you are dealing with a binary kind of thing or a classification, so you can use a multi-class classification also. This is used for multi-class classification, and this is a logistic regression model. This is since we use this is called logistic regression model. So this one also can have an error. You can compute the error values for it. However, for this it is slightly different. The error computation, etc., and then gradient descent. So it happens in a slightly different form. However, the message I am leaving is still the basic premise is same. You got to know how this equation for pattern recognition happens in a logistic regression part. That is all is the difference. We will look at logistic regression too tomorrow. We will do. So today we will try and understand the entire machine learning steps using the linear regression, and we will take 5 minutes break, and I'll come back and talk about the questions next 10 minutes and try and complete a full machine learning model evaluation today, including confusion matrix. We will make sure, even if it is a couple of minutes extra, I will complete it today. We'll go back and move to the break. All right, let's come back to see what are the questions that we are receiving, and we'll try and answer. So here video buffering is a question. You please refresh it. You go to the you go online, check there. Let's say you are checking YouTube here. You go there and let me open that and see our own. Yeah, apologies. I think we use it for different purposes. So you see recommendations. Now, this is where your FDP1, FDP2. Did I not mention FDP2 today? I thought Vishnu helped me with calling it as FDP2. All right. So you go there, and refreshing means you press here on the top and do that again. This is called, this is what we say, you refresh it. All right. Let's look at some of the questions that have come other than that. Uh, Feedback submitted. Thank you. How to submit? What is the link? Sir, if you want to compare two algorithms, then is it possible? Yes, it is possible, Ms. Suhasini. Now, in our algorithm, we will use one linear regression algorithm, and we will also use random forest classifier. Though I did not teach about it, we can compare and see what are the results of mean square error, what is the result on adjusted R square. We can see that. Instead of using linear regression, can we use SVM to get accuracy of prediction? Now, I have to tell you, ma'am, the types of algorithms you can use. Maybe it is time consuming, but I think I will talk about what are different types of algorithms we have, so that you get some sort of understanding. This is a bigger question. Can I use linear regression instead of linear regression support vector machine? That was the question that I got. For that, I have to first talk about what are different algorithms we have. Now, this this is more like a important cheat sheet for you. We need to know in terms of what are different types of algorithms we can have. You can have algorithms for this combination. You can have within the discrete and supervised learning, there are some algorithms that works. Now we are talking about linear regression, which is for regression is for continuous value and supervised learning. Now the models that will support this are linear regression will work. You have regression decision trees will work. Decision tree will work both for linear regression as well as classification purpose. This is the advantage with decision trees. Ensembling models, it will work ensembling models like uh, random forest. Yeah, you can say decision tree and XGBoost. XGBoost I will call extreme gradient boosting. It will work here as well as it works on the classification types. In the classification, what are different algorithms that are there? You have logistic regression. Then you have support vector machines are they are the classifiers. So support vector machine is, you have a classification like this, which are this side are all apples and this side are all oranges. Then it support vector creates some sort of a supporting boundary here, so that it will try and enhance this boundary. So this is more used for a classification purpose. You will use Bayes theorem. If you recall Bayes theorem probability, which is the genesis for many of the algorithms. Bayes is here. All the ensembling models will work. Decision tree will work here. So this is how we can choose. And you have clustering the other models that are relevant here. Here it is PCA. PCA is also supervised. Um, Supervised learning for yeah. So yeah, the principal component analysis is unsupervised learning that can be used for dimensionality reduction here. So this is how you have to choose algorithms. You can choose between them, but you can't choose this model, which is SVM, under linear regression. I will quickly see what are the other questions that I am having. Which encoding function is best one? See, I follow I will use this. Yeah, good. I'm hoping my voice is clear. I follow the label encoder of uh, scikit-learn. So if you notice in our thing, we have used label encoder. We have imported this for from sklearn pre-processing. You have get dummies, get underscore dummies. You can use that is under pandas. In pandas, you have get underscore dummies. My preference is this. So your link, we will see what can be provided. Can you explain machine learning models in detail because I am a big this course.